Everybody, this is Todd Frazee, and this is the video tutorial for the assembly for the S60-57 secondary piston assembly. Alright, so this is going to be should be your second assembly project. This is going to be the first one where you're going to download a model made by somebody else and import it into your assembly. It's a good exercise to learn, and it also help you out when you're designing components that you can look up specifications of real part numbers that you can order from a catalog and just download their models and save all that time you guys have for modeling. And you can also get the specifications downloaded so that if you need to switch parts to a different vendor, sometimes that's possible as well. So this assembly is 3 pieces. It's made up of the secondary piston rod and the secondary piston and a dowel pin that's 1/16 by 3/16. Let's pull up the menu or the drawing. A 16th diameter pin, 3/16 inch is of long. I made a 18-8 stainless steel, and we need one of those. The part number here, it should be in the notes, but the part number here is from a company called McMaster-Carr. So we'll be able to look up that part number. Okay, so to complete this project, you're going to need your S60-117 part file, your S60-119 part file. And so if you haven't modeled those two parts to their individual drawings, you need to go back and watch tutorials and model those individual components so that you can make the S60-57. Alright, and we need to download our hardware, which is the pin. That's the third component. So that's the first thing we're going to do. We're going to go to our browser, and you're going to go to www.mcmastercar.com. Now you want to do this, if you're working virtually, you want to do it through the browser, through the virtual computer. That way you can download it straight to there. Otherwise you have to download it to your local computer and use the file transfer. Okay, so if we go back to our drawing, I'm going to attempt to highlight the part number from the PDF and use Control-C, and we're going to go back to our browser and Control-V to paste that part number in McMaster-Carr's search tool. Now you could search through it as, fasteners, dowel pins, and it's a great resource for engineering because they give you a lot of information here. And also if they carry it, you're pretty much assured it's a fairly common item. It's not going to be hard to source elsewhere. So this brings me right to the catalog page for those 818 stainless steel pins, and it highlights the product that we're going to use. And if there's CAD data available, computer design data available, you're going to select on product detail, and it might make you create an account. It doesn't cost anything to have an account, so go ahead and do that if you don't already. Well, let's try it again. I'm going to put in my product. I'm going to go to product detail. And on this page, it's going to give you all the specifications, typically a drawing, an image, all the specifications of what standards it meets. And it looks like now they actually have an add-in for SolidWorks 2017 or newer. I wasn't aware of that. That's not installed in the lab, so maybe next semester I'll get that installed. But you can basically download a model in any of the following formats. So the 2D is going to be of a drawing itself, and then 3D models are going to be actual models, so that's what you want. Now let me take a moment to explain what these are. There's several formats here. SolidWorks is so popular that it's pretty much the only one that's native here, except for e-drawings, which I'm not familiar with. I think it's just a viewing software. But this shows you how popular SolidWorks is in the mechanical world. They don't list any other programs here that you can download a native. But IGES and SAT and STEP are universal file types. So SolidWorks can read the STEP and the IGES file. The STEP was designed for more modern files, solid models, and then the IGES file is an older format that was for the older CAD systems that use surfaces and individual lines. The PDF is going to give you a 3D PDF, so it's going to visually render the part in 3 dimensions, but you're not going to be able to bring that into SolidWorks. The 2D DWG file, that's for AutoCAD. The DXF is also a universal file that you can read in almost any CAD system, but it's only 2-dimensional information, so it's better for outputting drawings. If you were trying to do profile work where you're using a water jet or something, you might be able to use the DXF, but not that great. Basically, you would be importing a sketch to create a model with that. Then you have your 2D PDF, which is probably just going to be this drawing down here. And then you have the 2D SolidWorks, which is going to allow you to bring this drawing into SolidWorks directly and manipulate the drawing. So we're going to take 3D SolidWorks, and we're going to hit download. And it looks like if you select on it and you've downloaded it within the machine, it's going to download that right into SolidWorks for you. And they're using an older version so that they can support multiple versions. But if you notice, it puts the part number right into the name. You can change that, and the full description. So I'm going to go ahead and save this file. I'm going to do a save as, because I do want to change the name and the location. So I don't want to put it in the downloads area. I want to put it in documents where my other files are. And I'm going to chop off the name and just have it the part number. I'll be able to find that from the part number. And that way it's shorter. And when it shows up on your bill of materials, if you were to do a drawing, it would be just that for that field. Okay, we're going to hit save. And it's going to ask you, this is an older version of the file. Do you want to convert to the current version? Yes. So we're converting it from, I think, SolidWorks 2014 to the current version. Okay, hit yes. All right. So we're going to close the part file, and we can go back to our File Explorer, and we should see our 3 files together. Now in large assemblies, I will often make a folder that's just for hardware, and then those part numbers go in there so I know what's purchased versus what is modeled. And if I use this component in multiple assemblies, then I just have to download it the one time and just reuse it. But for this class, it's probably better you keep them all together because of the way Canvas puts its you're going to have to upload all 3 of these files, including the assembly file, which would be a 4th file, in Canvas, and I need the links to be independent of any other file structure you have. So we're going to leave it all at root here. Now we're going to go to SolidWorks. And we're going to go up here, we're going to say File, New, and we're going to create a new assembly. And it's going to ask us, hey, what's the first part you want to bring in this assembly? Is the 119, I mean the highest part number, which is the 119. So we'll select that. And remember, we want to temporarily turn on our origins. And this actually is not in a orientation like I want for the assembly. So if you see down here, there's an angle by axis that you can spin. So I want to rotate this around the x-axis 90 degrees and then do it again and do it again. Okay, and then that looks more in the orientation it's going to be used on the machine. And then I'm going to hover over origin and select origin, and it's going to place it like so. We'll go ahead and hide those origins. We don't need them. And we have our piston part. Okay, it should be fixed in space. You shouldn't see a negative over there, symbol over here, and the F in the bracket means it's the very first component. All right, so let's insert our next component, which we're going to select the 117. And we can just kind of place that in space. And if you take it and click on it, you can, with the left button, you can move it around. And if you click on it with the right button, it allows you to rotate it into position. So it depends on which mouse button you use to do your selections with. Okay, so this part, in orientation to this part, would be that this pinhole is concentric with this pinhole. It also has this tab centered between these two tabs. So we're going to use a couple different commands to set up those relationships between the two parts. Okay, the first one is we're going to center this, we're going to do the concentric, which we've done before. So we're going to go mate, and we'll select the inside cylinder, and then we select one of the two cylinders on the model. Okay, and in this case I'm not going to lock rotation because this is designed to spin between those two parts. So I'm going to hit accept. So now we have it's concentric. You know, it can be anywhere along here as long as it's concentric, and it can pivot. Okay, but what we want to do is constrain it so it's in between those pieces, and I think we should go shoot for it being evenly spaced. So to do so, we're going to go down here and we're going to close the standard mates, and we're going to open the advanced mates, and we're going to use the mate by width command. So let's pick on the mate by width. Okay, and you get these two boxes. So you have your mate selections with mate selections with tab selections. Now, it doesn't really matter which component you select is width versus tab. It will still figure it out. But the intent is on the width section, I'm going to go on the inside of the slot and select the two faces that make up the slot. Okay, so there's my width that I want to mate this part with. And now what is the tab selection? I'm going to select the two sides of the tab itself. And so the purple fields are the purple surfaces I selected, and the blue are the blue. Okay, and once that is done, you now have, it should be centered equally. So if we have any tolerance, you should have a little tiny gap on either side. Okay, well, we're going to accept that, and if I exit the mate command, I should be able to still manipulate this back and forth. It's concentric. There is no real collision detection, so I mean technically it would start interfering about here. The range of this part doesn't go that far in the real assembly, but yeah, it'll still let you rotate it even though there's a interference there. There is a part interference analysis you can apply. Now, if we really wanted to fully constrain this and get the minus symbol to go away, we would need to constrain this at an angle. I'm just going to leave it. It's okay if it's visual. And if you are going to do animation, you wouldn't have this fully constrained in that axis. All right, our last components are pin. So we've already downloaded it, so we're going to go insert component, and we're going to select our dowel pin for McMaster Carr, and we're going to open it and just pick anywhere out in space, and then we're going to right click on it. I like to turn the components roughly in the orientation. It's better at predicting how the mates work if you do that. Okay, and so this pin, you guessed it, this cylinder needs to be concentric with this cylinder. So we're going to go to Mate. You're going to select on the cylinder of the pin. And then we're going to select on the cylinder of, let's select on the outside part. Okay. And so it's going to snap to be concentric. Now the tolerancing on this drawing may not be coming through visually in the drawing, is that it's a press fit on the piston, but then on the rod it's a slip fit. So by selecting its concentric to this outside and locking its rotation, it shouldn't mess with the joint. It should allow it to still spin. Okay, we're going to accept that. But now this pin, can go anywhere as long as it's concentric right now. All right, so we're going to put in. Okay, so this pin is it's wider than the flange we're going to go in, and but it should be smaller in diameter than the actual piston, and we don't want this pin to interfere. So what we're going to do is we're going to use another tab relationship with this component. We want to equally space it so as it's pressed in. So we're going to go down and we're going to use an advanced mate, and we're going to select width, and our width selection is going to be the two ends of the pin. And then we want it to center itself between the tab. And we hit accept. And then what that does is the pin is equal distance sticking out, and we won't have any interference with the pin with the motion going in and out of the cylinder. Okay, that should be it for this assignment. Again, when you're all done, you should be able to tweak this back and forth. I would leave it close to vertical because when we go take this sub-assembly and put it in a larger assembly, it has to process a lot for those kinds of movements. So, and that concludes this tutorial for the S60-57 assembly. I'll catch you on the next one.